This is R.D. Sharma solution, class 12. Algebra of Matrices, MCQ we are taking. If A is 3 by 4 matrix and B is matrix such that A transpose B and B A transpose are both defined, then B is of type, or B order is to be found out. Now A is given as 3 cross 4 and A transpose B is defined. So what happens in transpose? The row becomes column, column becomes row. So we assume that B is R into C. R is for row, C is for column. You can also take it as M into N. So this is 4 into 3 now. Because A has, we have taken the transpose. Now this into B is defined. So the row has to be equal to 3. Because the column of A transpose has to be equal to the row of B. Now B into A transpose is also defined. So B is 3 into C. We don't know C. What is A transpose? It is 4 cross 3. Now B into A transpose is also defined. So the column has to be equal to 4. So the row is 3 and column is 4. So 3 into 4 is the order. B is of type 3 cross 4. 3 into 4. A is the answer. If Aij is a square matrix of even order such that Aij equals I square minus j square. Now you'll see that some of the options are, part of the options are correct. But the answer is D. How? First of all, the order means even, 2 by 2, 3 by 2, 4 by 4, sorry, and 6 by 6 like this. So let us take the example of 2 by 2. Now if we take the example of 2 by 2, this is 2 rows, 1 and 2. These are 2 columns, 1 and 2 columns. So this is A11, A12, A21, A22. Okay. Now you see, I squared minus j square, Aij. This is I squared minus j square, that is 1 square minus 1 square. This is 1 square minus 2 square, 2 square minus 1 square, and 2 square minus 2 square. Okay. So what do you get? This is just an example. Okay. So this is 1 minus 1, 0. 1 squared minus 4 is minus 3. And 2 2s are 4. 4 minus 1 is 3. And this is 0. Okay. So this is your A matrix. Now let us take the transpose of this matrix. When you take the transpose of this matrix, you will realize that it is actually a skew symmetric, because the A transpose will come as negative of A. So the A part, somewhat half of the A part is correct. That is, if I take the transpose, the row to column, 0 minus 3 will come here, 3 0 will come here, take the negative outside, it will be equal to negative of A. So this is indicating it is skew symmetric. But when do we take the determinant? Determinant is what? 0 into 0 minus of 9. That is 0 plus 9. 9 is the determinant. So the part here is all the options have no option determinant equals 9. Okay. So this is incorrect. Symmetric is incorrect. Skew symmetric it is correct. But determinant is 9. So none of these is the answer here. If A is given like this, A transpose plus A is identity matrix. So we'll take the A, that is this one. A transpose. So you can add A transpose with A or A plus A transpose. It remains same, because addition is it is commutative. So we have cos theta minus sin theta cos theta. Here we have, let us take the transpose. So row will become column. So first cos theta will come. Then we have minus sin theta. Here also the row will become column. Sin theta cos theta. And this is equal to the identity matrix. Cos theta is 2 cos theta. Minus sin theta is 0 when you just added. Sin theta again, minus sin theta, cos theta, 2 cos theta. This is equal to 1 0 0 1. So 2 cos theta is equal to 1. So let me just write like this. 2 cos theta equals 1. So cos theta will be equal to half. And that is equivalent to, half is basically, theta will be this pi by 3. Pi is equivalent to 180 degree. 180 by 3. That is, it will be cos 60 will be half. So you can just write cos theta as cos pi by 3. So theta will be equal to, when you generalize it, you know in trigonometry, we like the generalized equation. So it will be 2n pi plus pi by 3. C is the answer here. But you have to do it like this. Whole procedure you have to follow. A is expressed as the sum of symmetric and skew symmetric, then the symmetric matrices. So we have already done this type of question, whole process, but here only symmetric matrix is asked. So symmetric will be half A plus A transpose, skew symmetric will be half A minus A transpose. We just have to find out S equals half A plus A transpose. That will be the symmetric matrix. So let us take this one, 2 0 negative 3 4 3 1 minus 5 7 2, and we'll take the transpose and add it. Row will become column. So 2 0 minus 3 will become column, 4 3 1 will become column, and minus 5 7 2 will become column. Now just add it, and add and then divide it by 2. That will be your answer. So you can do all, because this is a multiple choice question. So the answer will be what is being asked. But the whole procedure is like this. So I'm just adding 4 0 is this 3 3 6 7 1 8 minus 5 minus 3 is minus 8 7 1 is 8 and 2 to 4. Okay, so we have to now divide it by half. So divide everything by 2. 2 minus 4, 2 3 4 minus 4 4 and 2. And you just have to see this answer. This is the answer. Okay? This A1 A option is the correct answer. This is the whole process which has been described, but you just have to do this half A plus A transpose. Out of the following matrices, choose the matrix which is a scalar matrix. Now, scalar matrix has to be a square matrix. It cannot be like this. Means m by n it cannot be. It has to be n by n. Now, these three are not there because they are not square matrix. But the first one, A, is a square matrix, and a diagonal matrix in which all the diagonal elements are equal is called the square matrix. So here 0 0. If you take the diagonal of the first one, they are equal. The number of all possible matrices of order 3 by 3 with each entry is 0 and 1. So there are 3 by 3, so 9 entries will be there. 3 3, so 3 3 is 9, and each entry can be 0 and 1. So 2 possibilities, 9 places, so it will be 2 to the power 9. 512 will be the answer. Which of the given values of x and y makes the following pairs of matrix equal? So we just have to equate these two equations, and then you'll see that what is the option? 3x plus 7 equals plus this 5, y plus 1 2 minus 3x, and we are equating it with 0, y minus 2, 8 and 4. So you see here, this 5 is equal to y minus 2. So from here it is clear for y is equal to 7. And you can take any of these. Let us take this one. 3x plus 7 equals 0. X will be equal to minus 7 by 3. Also 2 minus 3x equals 4. So that will give you another option. Okay, minus this is, see, y is 7. But what about x? X is giving us two values. X is giving us minus 7 by 3 another value. So it is not possible. A is given like this and Ka is given like this. So K, A and B are to be found out. So we have multiplied this A with certain K, and that is giving you 0, 3A, 2B, 24. So Ka is 0, 3A, 2B and 24. Okay. Now what we are suggesting here is, you have multiplied something with minus 4 and then you got 24. Okay, that is going to give you the K value. That is, this X is actually K value. So we are just equating the corresponding value. So this k or x, whatever you call, it will be minus 6. So this k has come as minus 6. Using this k, we are going to find out the a and b value. Now 0 is will not take 0, but we have multiplied 2 with certain k so that we got 3. So 3, and also multiplied 3 with something that is called k equals 2b. K is negative 6. So k will be equal to 2. This b will be equal to 3 into minus 6 is 2b. B is 3 into minus 6 by 2. 2 3 is 6 minus 9. B is minus 9. And what is 3? 2 multiplied by k is 3. And a is 2 into minus 6 divided by 3. 3 2 is 6. Is going to be negative 4. So this is how this value has come. K, A and B. Okay. I, J and B. So I and J has to be placed in all of these options. And then you see when B is coming. Okay. So B is coming when you put, so you have to start with A option. Put I as 1001, J as 01 minus 10 in the first equation here. So you have to multiply I with cos theta, J with your sin theta. So we are multiplying cos theta and then we are multiplying sin theta. What do you see? Just this is just a scalar multiplication. So cos theta will go inside, wherever 0 is there, just leave it. Now just add it. So it will be cos theta, this is sin theta, negative sin theta and cos theta. So this gives you what? This is V. This. So you have to see one by one, but we are fortunate that the first option itself has come. The trace of the matrix A. Now matrix trace is nothing but the addition of its diagonal. Okay. So can we find out the trace of any n by m matrix? The answer was 17 actually. Now if A is a scalar matrix of order n by n such that aii is k for all I, then trace of A is equal to. So we can take any of the n by n matrix, that is 1 by 1, 2 by 2, 3 by 3 like this. Now this is a scalar matrix. Scalar matrix n by n. And all the values at the diagonals are k. That is, this is k, this is k. And since this is a scalar matrix, all other element has to be 0. So A11 is k, A22 is k, A33 is k. This is already given in the question. So I am taking an example of 3 by 3 for example. So this, all the diagonals are k. Now the best way to understand this is when you have I and j, k is there. Now this is k is common. You can take k outside. But what is this trace? K plus k plus k, and this is 3 by 3. But I am saying n by n, so it goes up to n. So when you take the sigma, it will be n into k. So the answer is A. Okay, this is all about this exercise. Thank you so much. Take care of yourself.